Hello. First, to describe our problem, we need a supervised learning algorithm here because we have a specific data set, and also we are not classifying, we are trying to find the value, estimate a value, so the regression oriented model is working better here. We have few features, and also our inputs and outputs are numerical in nature. Also, the interpretability is important in my opinion here because we are managing a power plant here, so we have control in our inputs. So we need to find out which is important, which input is important for our output here. In building our model, because we have few features and also our features are numerical and continuous, linear regression is the first choice here. It's fast, works good with simple problems, and easy to interpret. Uh, Also, tree-based models are not considered here for me because it is more suitable to parametric algorithms in my opinion. Alternatively, I will try to find out which features are in relations with outputs in terms of non-linear one. So I will try to find out the logarithmic values of set inputs will be significant or not. This is my alternative algorithm here, alternative model here, not a different algorithm. Also, I will use R squared value as a metric to validate my different alternatives. In preparation, I split data to three. 60% of will be training, 20% of that will be validation, and 20% of that will be test. Also, I will use fixed validation instead of cross validation. In my first model, I just used the actual values of our four inputs is temperature, volume, ambient pressure, and relative humidity. In my training, as you can see the simplified model with three digits here. As you can see, the temperature, volume, and humidity has their negative correlation with our energy input, and ambient pressure has a positive correlation, albeit very low. All values have close to zero p-value. Also, our regression has a significance level of f and 93% of r square, so it works well. As I said in my second model, I tried to use at first all logarithmic values of the inputs, and as you can see, with adding the logarithmic value of volume, the actual volume value has been statistically insignificant because of a high p-value. So I decided to exclude that. Also, I decided to use just logarithmic value of volume, not all four. So I will still use four inputs instead of 8 or 6 because of simplicity is important here. And also, as you can see, our second model is here, and it has just a little higher r square, and all p-values are still close to zero. In validation case, I tried to use the validation data set here, and as you can see, the second model with logarithmic value of volume works slightly better, not that much, but has slightly more r square, so I will be using that model as the winner here. In our testing, as you can see, the r square value is still so close to validation, so our testing is working well. So this model is great at predicting the energy outputs. So as you can see, the results means the volume has negative correlation, and also the other humidity and temperature as well. As you can see, temperature has a lot higher coefficient here, and also as you can see here, the temperature has very linear relation with energy output here. The other two, especially pressure and humidity, has a bit scarcely correlated with the energy output. Logarithmic volume of volume is working well also. As you can see, just a little slight curve here. The temperature is the most important and most efficient one, most important effective one. The other trees are also good and working well in that model, but as we are putting our managing our plants, temperature will be our priority here.